Hello everybody, today we're going to be looking at question 39 from the Land-Type Numeracy test. So here's a question over here on the left. Display board. A rectangular display board on a classroom wall is 1.2 meters high, which we've got over here, and 8 meters long, which we've got over here, 8 meters long. And also mentions that it's not to scale. A teacher wishes to place A3 size posters onto the board in landscape orientation. So it already has the posters in landscape orientation, and here are the dimensions that it mentions. 420 millimeters across. So there's going to be lots of 420 millimeter posters going across the 8 meters, and 297 millimeters high, which will be going down this 1.2 meters of height of this display board. Now, what is the largest number of A3 size posters that can fit onto the board without overlapping? So this question is mainly just getting you to understand that you can figure this out even though they are of different units. So we have meters up here and millimeters here, but obviously they can be converted from one to the other. And I find in this situation it will be easier to convert the meters to millimeters. That way we won't be left with decimals. Because if you convert this one to meters, you'll have to divide by 1,000, which gives you 0.42, which isn't that useful. So I want to convert this one to millimeters, so 8 times by 1,000, which of course will be 8,000. And then to figure out how many 420 millimeter posters can fit across, then it will be 8,000 divided by 420. 8,000 divided by 420. 19. Now, it doesn't just say 19, it says a number slightly bigger than 19. Now, that means that there's going to be a little bit of a gap. That is mentioning that you can have 19 posters go across, and then there'll be a little bit of a gap where we can put 0.47 of a poster across. That's not enough to put a whole poster, but that's what that decimal place means. That's what these numbers mean, that we've got that much of a new poster can fit going across. The same thing is likely to happen when we go down. So converting 1.2 from meters to millimeters, we have to times by 1,000. And we get 1,200. And then if we get 1,200 divided by 297 millimeters, so remember 1,200 millimeters up divided by the 297 millimeters, which is how tall the posters are. This will tell us how many posters can fit vertically. And we can see that it says 4.04. And again, this means it can fit 4 with a small gap. And when I made a poster and a display board of the same dimensions to the correct scale, that's exactly what we saw. We see our 4 posters, and when we zoom in, we can see that there is a little bit of a gap down the bottom. That white space down the bottom, that is showing that it's not exactly 4 posters that fit there, it's 4 and a little bit of a gap. Now, if we've got 4 going down, we've got 19 that go across, as we can see here. Here's our 19, here's our 4. That means the amount of posters that can fit in total will be width times height. Width was our 19, 8,000 divided by 420. Our height was the 1,200 divided by 297. 1,200 divided by 297, that gives us 4. So it's just 19 times 4. You don't have to worry about these decimal place values because that's not a whole poster, that's just a part of a poster. So 19 times 4 will give us our answer. And there we have it. You'll be able to fit 76 posters, A3 size posters of these dimensions in landscape orientation on the board without there being any overlap. Hopefully this helps. If you've got any questions, just leave them below.